Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 6 to 10 of our 2020 AP Calculus AB Multiple Choice Practice Questions, volume number 1. Don't forget, we have 5 practice problems at the end of this presentation that we'd like you to try out in order to demonstrate mastery of the contents of this tutorial. To gain access to our entire playlist and other valuable learning resources, take a look at the link in the description below or just visit our website at mathgotserved.com. Alrighty, let's take a look at question number 6. In question 6, you're being assessed on how to apply the implicit differentiation technique in finding the slope of the tangent line, or also known as the derivative at a point. Alright, so if you take a look at the question, it says if x to the third plus 2y to the 1/2 equals 3y, what is dy dx at point 1, 1? Now, take a look at this equation for a second. What do you notice about this equation? This equation is known as an implicit equation. Why is it implicit? It's implicit because y is not isolated. All right, so keep that in mind. So implicit because y is not isolated. Because y is not isolated. Now, so if you're differentiating an implicit equation, what differentiation technique are you going to use? Well, it's indicated here. You're going to use implicit differentiation. All right, so one thing that is really important to keep in mind is that when you are differentiating implicitly, you want to check for disagreement. All right, so when you're carrying out implicit differentiation, don't forget to check for agreement. What does that mean? Well, you look at what you're differentiating with respect to. If it matches the variable that you're differentiating, like the x's, then you just differentiate that term and it's gone. But if it's another variable, you have a disagreement. And then you have to apply the chain rule there, and you have to differentiate the term first and add d of that variable, d what you are differentiating with respect to. That's what the whole idea of agreement is. So we're going to go over it in more detail when we start the problem, okay? So we have x to the third plus 2y to the 1/2 equals 3y. Now I'm going to rewrite this using radical format, okay? So it's quicker. So we can write this as x to the third plus 2 root y equals 3y. So we're going to differentiate the entire equation with respect to x. So we want to find d dx. All right, so when you're differentiating, there's going to be agreement here, disagreement here, and disagreement here, because these variables are different from what you're differentiating with respect to. So that basically means you're going to have dy dx when you're differentiating the second and third terms. Okay, let's do it. So if you differentiate the first term, that's going to be 3x squared. If you added dx here, what's going to happen? What is dx dx? It just divides out to 1, right? So that's why you don't have to bother with that. And then moving over here, 2 was the derivative of the square root of y. So you want to remember the fast way of differentiating radicals is going to be real helpful to you on the AP exam. So if you're differentiating the square root of x, the derivative of root x is 1 over 2 root x. If you don't remember this, you can just apply the power rule and you will arrive at the same result, but this is much faster. All right, so we're going to apply that here. If you differentiate, so you factor out the 2, differentiate root y, you're going to end up with 1 over 2 root y. Now, since there's this agreement, what do you have to add on here? dy dx, or you can add y prime. It's the same thing, okay? All right, when you differentiate 3y, the derivative is 3. And since there's this agreement, you add on dy dx. All right, so after differentiating implicitly, what we're going to do now is algebra, basically. We're going to collect all the terms with dy dx's to one side of the equation and then factor out dy dx and isolate dy dx. Okay, so collect, factor, and isolate. All right, so let's go ahead and collect all the terms with dy dx's. Let's collect them to the left side. So if you look at this middle term right here, these two divide out. And then you're going to have 1 over root y dy dx. And then this 3x squared, you subtract 3x squared from both sides. And then you add, you subtract 3x squared from both sides, and then you subtract 3 dy dx from both sides. So minus 3 dy dx, and then minus 3x squared. All right, so we just collected. So you collect all the terms with dy dx's. What you do next is you factor out. So let's go ahead and factor out dy dx. Let me partition my workspace here. So we're going to factor out dy dx on the left side. So it's going to yield 1 over root y minus 3 times dy dx factored out equals negative 3x squared. Alrighty. Now we're going to isolate. So collect, factor, and isolate. So if you want to isolate dy dx, you just basically divide both sides by the coefficient of dy dx. So let's divide both sides by 1 over root y minus 3 and 1 over root y minus 3. On the left side, this divides out. So you have your derivative dy dx, okay? So dy dx is equal to negative 3x squared divided by 1 over root y minus 3. Okay, this is the slope at any point, but in this particular problem, we have to find the derivative at 1, 1. So we found the derivative. Now we're going to fix it at this particular point right here, all right? So let's go ahead and do that. So we're going to find dy dx evaluated at 1, 1. What does that mean? It just means you plug in 1 for your x and your y, okay? So you have negative 3 times 1 square divided by 1 over root 1 minus 3. And then we just PEMDAS this real quick, and you get negative 3 over 1 minus 3 is negative 2. And then your final answer is positive 3 over 2. The answer to question number 6 is option letter A. Okay, so this is basically how you find the derivative at a point implicitly. Alrighty, let's take a look at question number 7. In question 7, you're going to be learning how to apply your differentiation techniques in finding the derivative of exponential and radical functions. Before we get started, let's take a look at the formulas that will be guiding our problem solving process. Remember, we have our collection of must-know AP Calculus formulas at mathgotserved.com. Do check it out and download it so you can know all the formulas you need to know to do well on your AP exam. Okay, so included in the formula sheet is the derivative of exponential functions. So 3 to the x, what is the derivative of 3 to the x? A common mistake that students will make is they confuse this with e to the x. No. When you're differentiating 3 to the x, this is going to be 3 to the x times the natural log of the base 3. Well, let's do it this way. I'm applying it to the formula, so let's do generally speaking. So let's say you have a to the x, okay? All right, so if you want to differentiate a to the x, it's going to be a to the x ln a. It's not just a to the x. Now, why is it that the derivative of e to the x is just e to the x? Well, this is the reason right here. When you're differentiating e to the x, you get e to the x because there is an ln e component here. But what is the natural logarithm of e? It's just 1, right? So this part is kind of invisible, divides out. That's why the derivative of ln of e to the x, is just e to the x. This is a special case of the derivative of exponential functions. It's not to be confused with the general case above here. All right. So this guy right here, the derivative of a to the x equals a to the x is wrong. This is a common mistake that students make, and you want to avoid that. Okay, now with that in mind, let's go ahead and do this. Oh yeah, another formula too. We went over this in number 6, but I'm just going to go over it again. Square root out. The derivative of a radical function is 1 over 2 root x. That's just a fast way to do it. All right, let's do this. So in this problem, we're looking for the derivative with respect to x of 3 to the x, the exponential function, plus your radical function root x. All right, so applying the sum and difference rules for derivative, we're just going to differentiate them individually. Find the derivative of 3 to the x, and then add on the derivative of a square root of x. Okay, and what's the derivative of 3 to the x? It's 3 to the x times the natural logarithm of the base, which is 3. 3 to the x ln 3. And then you add on the derivative of root x, which is 1 over 2 root x. Okay, so that is the answer to question number 7. And let's see what the answer is. Answer to question number 7 is option letter C. So this is basically how you apply your differentiation techniques in finding the derivative of a combination of an exponential and radical function. Okay, let's take a look at problem number 8. In problem 8, we're looking for the limit as x approaches infinity of 3x plus e to the x over ln of x minus 10. All right, so you notice here we're dealing with an infinite limits situation. So we're going to typebar this problem. So typebar. All right, so basically if it's top heavy, it's plus or minus infinity, equal way to divide, bottom heavy 0. If you have exponential functions, as is the case here, or logarithmic functions, you basically use relative rates. All right, so we're going to be using relative rates here to help us to solve this problem. Okay, so relative rates as x approaches infinity. We have to be careful here because the left and right end behavior of exponential and logarithmic functions are different, so you got to be careful with that. So relative rates as x approaches infinity. Just remember that as x approaches infinity, a logarithmic function, ln function, is basically the slowest, followed by your power functions, and then the fastest are your exponential functions. Okay? All right, so we're just comparing these because that's what we have here. So this is the slowest growing as you're tending towards infinity, okay? And then take that out. So this is slowest all the way to your fastest right here. So this is the relative growth rates for comparing how fast logarithmic, power, and exponential functions grow as x tends towards infinity. So how does that help us here? Well, since we're looking at limit as x approaches infinity, we want to look at the numerator and the denominator and assess which are the terms that are relevant towards infinity. In the numerator and denominator, we eliminate the other ones, and then we compare those two from the top and the bottom and see which of them is the fastest, and we can use Tybo to figure out the answer. Okay, so in the numerator, you have a race or competition between a linear and exponential function or power function with degree of 1 and an exponential. We can clearly see here that the exponential function is going to dominate. Oh snap, I got to take this sign. The exponential function is going to dominate. Always take this sign, don't forget. So that will dominate in the numerator. Okay. In the denominator, we have ln x and negative 10. Now, 10 is not even growing. It's a constant. Okay. So clearly, natural logarithm will dominate the constant function because it grows even though it's growing at a slow rate. Okay, so this limit reduces to, using relative rates, the limit as x approaches infinity of e to the x divided by the natural logarithm of x. All right, so we'll go ahead and take a look at this situation right here. Which one grows faster? E to the x is so much faster than ln x. Okay, so this is kind of like a top-heavy scenario. And if it's top-heavy, it's going to be plus or minus infinity. Plus or minus infinity. But since they're both positives, in this case is automatically going to be infinity for this right here. And the argument is, looking at your relative growth rates, is that, well, using Taibo, just remember that this is top heavy because using our relative rates, exponents is grows faster than log. All right, so towards plus or minus infinity, and it's positive because it's infinity here. We're looking at a fast growing function divided by a slow growing function. Another way to even verify this is you can just use L'Hopital's rule, because if you plug in infinity, you have infinity over infinity, which is indeterminate, and then if you differentiate, you just end up with x e to the x. Plug in infinity and you end up with positive infinity. But using Taibo is a quick way to just figure out what infinite limits are without much computation. Okay, so the answer to question number 8 is option letter A. That is how you find limits at infinity involving exponential, logarithmic, and power functions. Alrighty, let's take a look at question number 9. In question number 9, you're going to be assessed on how to find the area between two curves. So before we get started, let's take a look at the formula that will be guiding our problem solving process for this example. All right, so as a formula for the area between two curves, formula is as follows. The area is the integral from x left to x right of f top minus f bottom with respect to x. We're using dx in this particular problem because of the orientation of our functions. We have a top-down orientation. If you look at the functions that are given, they're functions of x, right? So that automatically tells us that this is the case right here. For other cases, for your horizontal configuration, just go to mathgotserved.com on the AP Calc. We have our formula sheet there, and you can see all the formulas that you need to know to do well on the exam, including the area formulas. All right. Okay, so all we need to do here is find out what our top bottom functions are, x left, x right, integrate, applying FTC 1, and then we'll be good to go. All right, so let's identify our functions. So we have a linear function here and a quadratic function. So if you think about it, in order for them to bound an area, considering the fact that this quadratic function is downward opening, is it obvious that the top function will have to be the quadratic? So you have a quadratic function on top and a linear function on the bottom, right? So they can bound an area. The reverse will not make any sense. Okay. All right. So let's go ahead and do it. So f top is going to be your quadratic function, which is 7x minus x squared. And then f bottom is going to be your linear function. Okay, let me just give you a visual of what we're talking about. Some of you might be able to visualize it in your head, which is excellent, but let me just give you a visual. So we have a situation like this. We have a quadratic function. It looks some. Let me sketch it again. It's just a rough sketch, just to give you a visual. So we have a quadratic function that looks something like this, and then we have a linear function that looks something like this. You know what y equals 4x is, okay? So this bounds. Notice the question says the bounded region by the two graphs. So it bounds this particular region right here. So we're trying to find out what this area is. Okay, so they both start from 0 and then they both intersect at a particular point right here. So let's go ahead and figure out what that point of intersection is, because we know that the left, well, we know what x left is going to be 0, right? And then we have to figure out what x right is. But let's assume that we don't know what x left is, so let's find both of them algebraically. Let's find x left and x right. All right, so this will be x left right here, and the x right will be this point of intersection. Now, how do we find x left and x right? We just simply set both equations to each other and solve algebraically. Okay, so we have 4x is equal to 7x minus x squared. Okay, so we can add x squared to both sides and subtract 7x from both sides. So you have x squared minus 3x equals 0. Factor out x, and you have x minus 3 equals 0. If you use a zero product property, x is equal to 3 or x is equal to 0. Okay, so our x left is 0 and then our x right is 3. It's not drawn to scale, so all right, so we have everything that we need now. So we're gonna just put it all into the formula. Okay, so x left is a smaller one, is 0, x right is 3. And then we have f top and f bottom here. Ladies and gentlemen, we're ready to go. So the area is going to be the integral from 0 to 3 of f top, which is the top one. F top is the green function, right? So f top is our quadratic, 7x minus x squared minus f bottom, which is 4x. All right, the bottom function is a monomial, so I don't have to put a parenthesis. But if you have a binomial, you want to put a parenthesis there because the signs will flip when you distribute. Alrighty, so let's simplify our integral first, and then we're going to use FTC1 to finish this off. So we have the integral from 0 to 3 of combined like terms. We have negative x squared, and then 7x minus 4x is plus 3x. All right, so let's go ahead and integrate. So FTC1, you integrate and evaluate it at the top minus the antiderivative evaluated at the bottom, okay? So when we evaluate it, let's find the integral. If you evaluate the integral using the power rule, it's going to be negative x to the 2 plus 1 over 2 plus 1 plus 3x to the 1 plus 1 over 1 plus 1. We know what the drill is here. Okay. Oh. Moving right along, we're going to have negative x to the third. Well, we're evaluating it from where? We're evaluating it from 0 to 3, the entire thing. So let's make it look pretty. So we have negative x to the third over 3 plus 3x squared over 2, evaluated from 0 to 3. So plug in the top minus you plug in the bottom. So if we plug in the top, we're going to have negative 3 to the third over 3 plus 3 times 3 squared over 2. When you plug in 0 in these two terms, the entire thing becomes 0. Okay, so you don't have to bother yourself with that. Let's go ahead and simplify this. This becomes negative 27 over 3 plus 3 times 3 is 9, 27 over 2. And then we can simplify this further. This becomes 27 over 3 is 9, so we have negative 9 plus 27 over 2. All right, so make this into fraction, times this top and bottom by 2. That gives us, what does that give us? Negative 18 over 2 plus 27 over 2. And then you combine the numerator, keep the denominator, you're going to end up with 9 over 2. Our final answer for question number 9 is option letter D. That's the answer right there. All right, so ladies and gentlemen, this is basically how you find the area between two curves by applying the fundamental theorem of calculus, part 1. Alrighty, let's take a look at question number 10. In question 10, you're going to be looking at how to find the derivative given a graph. Basically looking at for the derivative at a point or the slope of a tangent line at a point given the graph of the function. Alright, question 10 reads, the graph of f is shown to the right if g is the function defined by g of x equals quantity 3x squared minus 1 times f of x. What is the value of g prime of 5? Alright, so this graph right here is a graph of f of x. Alright, so let's go ahead and do it. We want to find g prime of 5, okay? So if you're looking for a g prime of 5, it's a two-part process. Very important to know that. To find g prime of 5, you want to break it up into two parts, okay? First thing you want to do is a calculus step where you find the derivative of the function. And then secondly is the algebraic component where you evaluate your derivative at the specified input value, which is 5 in this case. Okay, so this, what we're looking for, is also known as the slope of the tangent line. Now, let's go ahead and get started with the first part. So for part 1, we're going to try and find the derivative of the function. All right, so for part 1, we want to find g prime of x. So g prime of x. All right, so g of x is given by the quantity 3x squared minus 1 times f of x. So how do you differentiate a scenario like this? Notice you have a product, right? So that should tell you what formula we're going to use. We're going to be using the product rule. Okay, so let's review what the product rule is again real quick. So if you have the product of two functions and you want to find the derivative, is v u prime plus uv prime. Alrighty, so in this particular situation, this quadratic binomial will be our u, and the function f of x will be our v. So when we apply the product rule, the derivative of this function, g prime of x, is going to be v, which is f of x u prime. If you differentiate 3x squared, you get 6x, because the derivative of 1 is just 0, right? So that's vu prime plus u, which is quantity 3x squared minus 1 times v prime, which is f prime of x. There you have it. Now we're going to find the derivative. We're done with part 1, okay? There's no cosmetics that we need to do here. So let's go ahead and attack the second part, which is this should be purely algebra, but we have an f prime of x scenario here that will require us to use calculus and algebra. So we want to evaluate the derivative that we found at the specified x value, which is 5. Okay, so what does that mean? Well, it just means we just input 5 everywhere we have x. So f of 5 times 6 times 5 plus 3 times 5 squared minus 1 times f prime of 5. There goes another slope of a tangent line again that we have to address. So let's go ahead and do this. So g prime of 5 is as follows. So f prime of 5 just means evaluate the function at 5. So f of 5 is 0, as you can see here. If your input is x on the graph, then your output is going to be 0. So f of 5 is 0. 6 times 5 is 30. Doesn't really matter because it's going to go away anyway. So this is 30 plus 5 squared is 25. 25 times 3 is 75. So we have 75 minus 1. What is this f prime of 5 here? How do we find f prime of 5? Given the graph, how do you find the derivative? Well, it's nice that we have 3 linear segments here, so we can easily determine what the derivative is. If we make use of... Alright, to find f prime of 5, we're going to be finding the slope of the tangent line at 5, okay? Now, since this point right here is in the interior of a straight line, this entire line is equivalent to the tangent line. So this line is the tangent line, all right? So whenever you're looking for the derivative of an interval, where the function is linear on that interval, that function represents your tan line. So all you just have to do is find the slope of the line because the slope is constant on that interval. So to find f prime of 5, we're simply going to use algebra. So to find f prime of 5, we're just going to look for 2 lattice points that can easily help us to evaluate the rise over run. Okay, so let's look here. I like to pick this point right here. This is a nice little lattice point. And this is another one right here. You do rise over run. So in this particular case, we're dropping 2 units. So we have a negative rise, -2, and we're running 1. Okay, so your rise over run is going to be -2 over 1. And that will represent the slope of the tangent line because the line segment, because it's a line segment. All right, so plug it in here. Times -2 for f prime of 5. So all that's left is just arithmetic. We're just going to PEMDAS this equation and get the final answer. All right, so for simplify, we're going to have g prime of 5 equals 0 plus 74 times -2. And when you multiply 74 by -2, you get -148 as the value of g prime of 5. Ladies and gentlemen, the answer to question number 10 is option letter B. Alrighty, now it's your turn to have some practice. We have 5 practice problems that we promised we're going to have you work on earlier, displayed right now. So go ahead and pause this video presentation at this time. Go ahead and try out those 5 practice problems. When you're done, click on the playback button and we're going to reveal what the answers to these problems are. Alrighty, welcome back. Let's go ahead and take a look at the answers to these practice problems. The answer to question number 6 is option letter C. For number 7, the answer is option letter D. For number 8, the answer is option letter C. For number 9, the area between the 2 regions, the answer is option letter A. And then lastly, for question number 10, g prime of 2, the derivative at 2 of this function is 5 over 18, option letter B. So how well did you do in these practice problems? Let us know in the comment section below what you scored. If there are any questions about any of these practice problems or what we went over in the presentation, just specify it in the comment section below and we'll be more than glad to assist you. Thanks so much for taking the time to watch this presentation. We appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming AP Calculus AB exam, do give us a like or a thumbs up. Do not forget to subscribe to our channel for updates to other great math tutorials such as this. If you have any questions or comments, just put it in the comment section below as indicated earlier. Tons of support resources can be found at our website, mathgotserved.com, under AP Calc, and also in the links in the description below. Thanks again for watching and have a wonderful day. Goodbye.